All right, guys. If you have not downloaded Bellwork, go ahead and hit pause and go and download that from Notability. And let's start with day 1. Join each shape to the matching net. So a net is just an unfolded version of a 3D shape. So the first one, the cylinder, should be matched with the one that has 2 circles and the rectangle in between. The next one is a cube. There are 2 that look like it could be a cube, but we want to match it with the one where all the sides are the same. The next one is a triangular prism. So the sides here are rectangles, but the 2 bases are triangles. So the one that matches is the very first one. Next is a cone. So it has a circle for a base. And then when we unfold it, it looks like that. Next one is a pyramid. So all of its sides are triangles. And then the last one is the rectangular prism. That's it for day 1. Day 2. Either pause and come back tomorrow or continue for day 2. There's only one for today. Find the surface area using a net. So you have to draw a net, a rectangular prism. So remember, rectangular prism looks like that or that one. We're going to use this type of net for all of our rectangular prisms. So first, we've got 2 rectangles. And then we can connect these here. So it should look something like that. Remember, it should have 6 sides. The easiest way is to choose, I usually choose the longest length and make that all of the labels down the middle, because all of these sides need to be the same. And then I choose the next longest, and I go with these ones down the middle here. And if we were to fold this up, this side here would match with this side here. So these are also going to be 5s. And then that leaves these ones that all connect to be the last length. So now to find surface area, you're just finding the area of every single side. So for this one, it would be 7 times 5, which is 35. If we look 2 away, this one down here is also 7 by 5, so it would be 35 as well. This one on the end, 7 times 2 gives us 14. And again, if I look 2 away, there's another one that's 7 by 2. So our last ones, 2 by 5, would each be 10. And then to find the total, you add them all up. Remember, you should have 6 sides, and there should be 2 of each number. And it's fine if you use a calculator for these. So we've got 35 plus 35 plus 10 plus 10 plus 14 plus 14. 118. And our label would be centimeters squared. It's surface area, so it's still area. That's it for day 2. Day 3. You're either continuing, or if you want to pause and come back, look for day 3. Day 3, we're doing drawing a net again. This time it's a cylinder. So a cylinder has 2 circles with a rectangle in the middle. Maybe. Close enough. So it has a radius of 10. So that means halfway across the circle is 10. And then the height is 12. Same thing as with a prism. We're going to find the area of all of the shapes and add them together. For the circle, area equals pi r squared. So area equals pi times 10 times 10 again because it's squared. So our answer is either 100 pi, if you want to leave it like that, that's fine, or 314. This circle down here is exactly the same. I don't need to do it again. Just know that it's the same. So then the middle is a rectangle. So area equals length times width. But the length of this rectangle is the same as the distance around the circle. So that's called pi times diameter, circumference. So area equals, the diameter was 20 because halfway across was 10, so all the way across is 10, is 20. So 20 pi times the width is 12. Again, if you want to leave it in terms of pi, 20 times 12 gives us 240 pi, or 240 times 3.14, 753.6. Last step, find the total. And again, you can leave it in terms of pi if you want, so we can either do 100 pi. We've got another circle that's 100 pi. And then the middle was 240 pi. We're going to add those all up. Or 314, 314, and 753.6. If I leave it in terms of pi, 440 pi, or 753.6 plus 314 plus 314, 1,381.6. If I double check 440 times pi, same answer. That's it for day 3. Day 4, either continue or pause and come back for day 4. Day 4, you're finding the surface area for both. So, first one, cylinder. Let's go ahead and make our net. And then make sure we include the labels. So the diameter this time, so that means all the way across is 12. And the height is 5. First, let's find the area of the circles. So area equals pi r squared. Pi times the radius would be 6. All the way across is 12, so the radius is 6. So I can either have 6 times 6 is 36 pi, or 36 times 3.14, 113.04. Remember this circle down here? It's exactly the same. I don't need to do it again. That leaves the rectangle in the middle. The distance around the circle is the same as the length of the rectangle. So that would be circumference pi times diameter, so 12 pi. So area equals length times width. Area equals 12 pi times the width is 5. 12 times 5 gives us 60, so either 60 pi or times 3.14, 188.4. Last step, add them all together. Either all in terms of pi, 36 pi, 36 pi, and 60 pi. So 36, 36, 60, 132 pi. Or, if I go with already multiplied by pi, 113.04, 113.04, and 188.4. So if we add those all up, we get 414.48. Remember, these answers should be the same, so if I double check, 132 times 3.14 should be the same answer. Second one for today. A rectangular prism. So remember, that should have 6 rectangles. Whoops. Go ahead and connect these. Obviously, mine's not perfect here. That top and bottom side is not the same, but that's okay. So now, again, if you remember, I find it easier to start with the biggest number and make that all of these, because those would all be the same length. And then I go with the next biggest, so 12, and that goes down the middle here. And if I were to fold this up, this side right here would match up with this side here. So that makes these 12s as well. So then the last one, for this one it's 8. Should kind of make like these little L's here. They should all be the same. So then to find the area of each rectangle, we just multiply the sides. So 12 times 20 gives us 240, which makes this one 240 as well. 8 times 20 gives us 160. This one 2 away should also be 160, which leaves these last ones here. 12 times 8, 96, which makes that one 96 as well. So again, I should have 6 numbers that I'm adding, and I should have 2 of every number. So 96, 96, 240, 240, 160, 160. And we're adding those all together. So 992. And that's it. Day 5, either pause and come back later, or if you're going to continue, go ahead and continue. Day 5, we're trying to find the missing angles and solve for x. So for number 1, this is a straight line, which means they are supplementary angles, and they should equal 180 degrees. So to find x, I would do 180 minus 130, and that leaves 50 degrees for x. Number 2, also a straight line, so they're also supplementary, so they equal 180. This one's not as easy. It's not just subtracting. So we need these 2 angles added together to equal 180. 5x minus 18 plus 4x plus 45 equals 180. First step, combine like terms. 5x's plus 4 more gives us 9x. And then for our numbers, negative 18 and 45. So 45, minus 18 gives us 27. Next step, subtract 27 on both sides. This gives us 153. Last step, divide by 9. 153 divided by 9, 17. So x equals 17. That's not all they asked us to do, though. We have to find x and all of the angle measures. So that means you're now plugging x equals 17 in anywhere there's an x. So for this one, 5 times 17. And then minus 18. So this one would be 67 degrees. And then this one up here, again, replace x with 17. 4 times 17, and then plus 45. Remember, these 2 angles should equal 180. So if I take 113 plus 67, it equals 180. So that works. Day 6. Either pause and come back or continue. Day 6, number 1. These three angles equal 90 because of that 90 degrees. That makes them complementary angles. Again, that means these added together. So x plus 3 plus x minus 1 plus x plus 1 equals 90. Combine like terms. 1, 2, 3 x's. And then 3 minus 1 gives me 2, plus 1 is back to 3. Subtract 3 on both sides. 3x equals 87. Last step, divide by 3. So x is 29. Again, we're not done. It also asked us to find the angle measures. So that means I'm going to go back through, and anywhere there's an x, I'm going to replace it with 29. So for this first angle, 29 plus 3 gives us 32 degrees. For the middle angle, 29 minus 1 gives us 28 degrees. And then this last one, 29 plus 1, 30 degrees. When I add these all up, I should make sure they equal 90. 32 plus 28 plus 30. They do. Second one, these also equal 90. They're complementary angles. This one, there's nothing to really solve for. You're just doing 90 minus 62. (28 degrees). Number 3. 2 ways to solve this one. A triangle should equal 180 degrees. So if I do 180 minus the 51 and minus the 42 they gave us, this angle should be 87 degrees. And then for this angle here, it's a straight line. So 180 minus 42 should give me my answer. 138. Or these two that are opposite should also be added together and equal the same thing. Let's check. 87 plus 51. Look at that, 138. Last one today. You're finding angles 1 and 2. First one, 1 is vertical to the one that was given, so that means they are equal. So angle 1, nice and easy, 18 degrees. So then to find angle 2, it forms a straight line with either angle 1 or the one that was given, which is 18. So 180 minus 18. So angle 2 should be 162 degrees. This last one over here that wasn't given would also be 162. So vertical angles, the ones that are diagonal, they share this center, are equal. They're the same. Day 7. Number 1 for day 7. Which side lengths can form a triangle? So by now you should know that the two smaller sides of a triangle, so the two smaller sides, when you add those together, they need to be bigger than the longest side. So the first one, they're all the same, so pick any two. 5 plus 5 is greater than 5, so that one works. The next one, these two are the same. 14 plus 14 gives me 28. That's bigger than 22. That works. Next one, 4 and 9 would be the two smaller sides. 4 plus 9 equals 13. That doesn't work. It has to be bigger. Last one, the two smaller sides would be 17 and 10. That's 27, which is bigger than 25. So that one works. Number 2, two angles in a triangle are 25 and 90. What's the third angle? All triangles have to equal 180. So 180 minus 90 minus 25, 65. Last one for today. What are triangles' angles measured in? Those are always degrees, every single time. And some units at the sides could be in centimeters, inches, meters, feet, anything like that. So angles are always degrees. The sides would be something like centimeters or inches. Last day of bell work. Day 8. Day 8, by now we should know what a unique triangle is, whether something forms more than one triangle or no triangle at all. When it says justify your answer, that means give the conditions that were given. So the first one, the angles are 25, 25, and 120. So that could be more than one triangle, but let's check. 25 plus 25 plus 120, that's only 170. So that's no triangle. When you justify your answer, it's no triangle because it doesn't equal 180 degrees. Number 2, the angles of a triangle measure 100, 10, and 70. That one would be more than one because all triangles equal 180 degrees. So we can't specify what size this triangle would be. It could be 6 inches by 10 inches by 12 inches. We don't know. But they all equal 180. So it could be any size. The next one, 3 sides of a triangle are 12, 10, and 20. The 2 smaller sides, 12 plus 10 gives us 22, and that's bigger than 20. So this one would be unique because side, 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 and 12 plus 10 is greater than 20. Next one, 3 sides. So this one could be side, side, side. But 4 plus 5 is 9. That's not bigger than 12. So this one's no triangle because 4 plus 5 is not bigger than 12. Next one, 2 angles of a triangle, each measure 50 degrees. The non-included opposite side of one of the 50-degree angles is 5 inches long. So they gave us 2 angles. So that'd be A, and a non-included opposite side. So AAS. So that is unique because angle, angle, side. Next one, a right triangle with 2 sides that measures 3 centimeters and 6 centimeters. It's a right triangle, so they gave us an angle, but they gave us 2 sides, and they didn't tell us if it was in between or on either side. So remember, we can't have that word. So, more than 1. Number 7, 2 angles of a triangle measure 70 and 30. Angle, angle, and the included side is 8, ASA. So that one's unique. And it would be because angle, side, angle. Last one, an 80-degree angle has sides of 5 centimeters and 7 centimeters. So since the angle has both those sides, it would be side, angle, side. So unique because side, angle, side. Remember, we can have SAS, but we can't have, so that's the difference.